This lesson is going to be on expressing radicals in simplest radical terms. When we're expressing radicals in simplest terms, we have to make sure that there's no factors that are perfect squares of the given number we have. So here we have radical, or square root 72. 72 is not a perfect square, but I can split 72 up into 36 times 2. The reason why I picked 36 is because 36 is a perfect square. You want to try to find the largest perfect square that goes into the given number. Now, since they're being multiplied, I can split them up into radical 36 times radical 2. Radical 36 is 6, so that's going to come out of the radical. And 2, I cannot take the square root of, so I would leave that. So my simplest terms answer would be 6 radical 2. Now in this problem we have numbers and variables as well. When you're taking the square root of a variable with an exponent, you can only take the square root of a variable with an exponent of an even number. So the square root, or radical n squared, is equal to n. Radical n to the fourth is equal to n squared. Radical n to the sixth is equal to n to the third. You're dividing the exponent by 2 because when I multiply n times n, I add the exponents, that gives me n squared. N squared times n squared is n to the fourth. N to the third times n to the third is n to the sixth. So I'm going to start by first simplifying the 50, then I'm going to work on the n to the third. So radical 50, I can change 50 into 25 times 2. Now n to the third, I want to find the largest even exponent that I can factor out of n to the third. That gives me n to the second, and then I'm just left with n. Now I can split this up, radical 25 times radical 2 times radical n squared times radical n. You don't always have to split it up. You can just go right from this step to your final answer. Radical 25 is 5. Radical 2, that's going to stay in my radical. Radical n squared is n. And radical n, that's going to stay inside my radical. So my simplest radical terms is 5n radical 2n. Radical 32, n to the ninth, x, h to the fifth. So I'm going to split it up in pieces. I'm going to do the 32 first. 32, I can split up into 16 times 2. N to the ninth, I want the largest even, so it's going to be 8. So I have n to the 8th times n. The x, can't make that anything with an even exponent, so it's just going to stay as x. And then the h, I'm going to split that up into h to the fourth times h. Now I'm just going to go piece by piece. 16, I can take the radical of that, it's going to be 4. So it's going to go outside my radical. 2, I cannot take the radical of that, so it's going to stay inside my radical. N to the 8th, the square root of that is n to the 4th. And then n is going to stay inside my radical. X stays inside my radical. H to the 4th, square root of that is h squared. And then the h stays inside my radical. So this would be my answer in simplest terms. Negative 4 radical 192x. The negative 4, I'm not going to worry about just yet. I'm going to leave that outside my radical. Now 192, I'm not sure of all the perfect squares that go into that, but I know 4 goes into that. So I could split that up into 4 times 48, and then the x is going to stay. Now I have this negative 4, radical 4 is 2, so I'm going to multiply it by 2, and then I have radical 48 and x inside my radical still. I can multiply these numbers outside, so I have negative 8 radical 48x. Now I can simplify 48 even more. 48 I can split up into 16 times 3, and then the x is going to stay. Now I have negative 8, radical 16 is 4, and then I keep the radical 3x. Negative 8 times 4 is negative 32, radical 3x. Now another way I could have done this problem is from the beginning, I could have split the 192 into 64 times 3 times x. Now, radical 64, that's 8. So I have negative 4 times 8, and then radical 3x. Negative 4 times 8 is negative 32, radical 3x. So I still end up with the same answer. Even if you don't take the largest perfect square at first, you just have to keep simplifying it till you cannot factor out any other perfect squares.